Okay, let's look at the question 2. Question 2, given fxy equals to ay square x 1. First, draw the non-zero definition region of fxy. Okay, since we know that y x y, right, we can draw the plot x y, sorry, right, yeah, and actually the region is this. What's more, we also need to notice that y is larger than 1, so we draw the line. This is 1, 1, this is y. Okay, so it's a region. So second question is find A so that fxy is a valid joint density function. Okay, since we know that fxy equals to ay square x1 greater than 1 and x, right? We can get that f1 to infinity y a 1 dx it's a d, and dy is equals to this is equals to 1 ay dx, right, dy it is equals to ay square ln x y dy ln y square, right, dx. Oh, sorry, dy. Right. In this formula, we can define w equals to ln y equals to ew. So in this way, we can do that. Sorry, I've got something. This is actually It's 2, right? It's 2 log y, log y minus log y, right? I'm sorry, it's actually 2 log y, so it is actually a2 0 to infinity e to w e d w, no, sorry, e to w d e w equals to a2 0 infinity w e to w e w d w, right? So this is equal to a2 w e minus w dw equals to a2 w de minus w. In this way, we can find that a2 equals to w e minus w to infinity minus e minus w dw, right? We need to ensure that fxy is a valid joint density function, so it is equal to 1. In this way, we can find that a equals to 2. Okay. The third problem is find and draw some marginal density function fx and fy. Okay. In this way, first let's solve that fy equals to fxy dx y, this is equals to 2y square dx, right? We have solved this before. We can call the direction, call the result directly. It is log y square. In this function, the y range is y larger than 1 smaller. We need to ensure that y larger than y minus 1, so y larger than 1, right? Other situation, y equals to 0. So if y equals to y square log y, otherwise, okay, we'll find the fx. Fx equals to fxy dy, it is equals to x1 infinity y x, right? right? Dy it is equals to square. This way x need to 0 to 1 because we in different range of x, y, this x larger than x, y, right? So if the x range is this, we need to ensure that x larger than 1, smaller than x larger than 0 and smaller than 1. Otherwise, fx equals to x infinity. It is equals to 0 x square 1. This is way larger than 1, smaller than. So fx equals to 0 to 1, 1 to infinity. We can draw this two. We can draw this two function. Y f y1 x f x y. This is 1. Okay, so last question is verify fx and fy are valid density function. What valid density function? We need to ensure that 1 square drawing y dy. This way, we need to ensure that this equals to 1, so it is actually a valid probability density function. What's more, f0 to infinity, f x dx equals to equals to 1 infinity dx is equal to so this is also a valid probability density function. Oh, we solved the problem totally. Thank you.